and that moves our tilt axis ever so slightly. And in fact, our tilt changes from 22 degrees to 24.5 degrees. Now we are at 23.5 degrees coming off of 24.5 degrees. Now this cycle is about 40,000 years. So these are the cycles. We have to add them all up to see what happens. Let me give you a quick comparison just with that one tilt axis, we call that obliquity, and another planet. Let's look at Mars. Here you see the obliquity of Mars over 10,000 years relative to the Earth, where the Earth changes from 22 degrees to 24.5 degrees. You see Mars changes 48 degrees to 15 degrees. Huge changes occur on Mars. This is why Mars has gone through enormous climate changes. This is also why we have found the old North Pole, a huge amount of water, ice buried at what is today mid-latitudes, because it used to be the old North Pole of Mars. An enormous amount of water and resources that will allow humans to go then from the moon to Mars and be able to live off the water that's there. So how is it that our planet, its tilt, its obliquity is so small in comparison to that of Mars? Well, it turns out it's the moon. Our moon keeps the Earth uncommonly habitable. It stabilizes the Earth's spin axis. It slows the Earth's rotation rate, and it causes lunar tides. These are all tremendously important, we believe, for life on Earth, for the emergence of life on Earth, and the development of complex life, us, humans. Now, let's talk about these cycles into more recent time and into the future. So here's the cycles that we're talking about right now: eccentricity, the precession, and the tilt. And as you can see, they all have their own cycle. And this produces, when you add them all up, a change in the temperature, the average temperature of the Earth, which we now measure on a regular basis. Think of a grid of thermometers all around the Earth, even over the ocean, and they make measurements of the temperature every 30 minutes for a whole entire year. That data is brought together, averaged, and come together, and you come up with one number, the average temperature of the Earth. Well, as the Earth changes in its orbit, in its obliquity, it changes in eccentricity, that number goes up and down. So even in the last 10,000 years, natural changes have changed that number by at least 6 degrees C. All right, 6 degrees Celsius. In fact, we're just now coming out of an ice age. So this is the topic I wanted to really bring to everyone's attention. 12,000 years ago, before present, if we were to look at the Earth and from space and look down and see where the tundra is, where the forests are, where the savannas are, and the polar caps, this is pretty good representation of what we'd find. And we know this because we can find the geological record that tells us that. In the northern hemisphere, we see a huge polar cap, okay? And what we see in the United States is Canada is gone. It's under a mile of a glacier. It's gone. And in fact, it goes into the United States, this glacier, where as it began to recede only 12,000 years ago, it left us the Great Lakes, the St. Lawrence Seaway, the Hudson Bay. In Europe, it's down over England, completely gone, and into France. And as you can see, the weather patterns change accordingly. And in fact, what we believe, even as far back as 8,000 years ago, which is not very long ago, Africa was green. It was the green Sahara. It had huge lakes, enormous number of rivers. We can determine past Neolithic humans living and working in this area from many different opportunities to peer through the sands, seeing the riverbeds, seeing the lost cities. Lake Chad was huge compared to what it is today. But more importantly, what we find are rock paintings, Neolithic rock paintings. These are called the Tassili frescoes. They give us depictions of village life in the middle of the Sahara. And these are herding cattle. They're hunting. They're wedding processions. They're all the normal elements of life that you would see today. And it's across the Sahara as these beautiful frescoes are being documented and illuminated today. So Africa had an enormously beautiful and rich history. But of course, over time, as the Milankovitch cycles kicked in and added up to change the content of the polar cap, as it shrunk over time, the weather patterns changed. The Atlas Mountains prevent a lot of precipitation from coming into Africa. You started with a period of drought. But unfortunately, it wasn't a small drought. It was 1,000-year droughts. This forces that Neolithic population to move. They move to the shoreline. They move to Central Africa. They went over and established the Egyptian culture. Now, today we know when we go out in the Sahara, vast regions of the Sahara is full of sand. Where does the sand come from? Sand comes from rivers, fast-moving rivers that destroy or round rock, bust it up, create riverbeds of sand. But then when the evaporation occurs, the sand blows out of these rivers and is covering parts of Africa in the Sahara. This is how and why we have the Sahara, the look and feel of the Sahara today. We need to understand these huge climatic cycles to really determine what's happening to the Earth. So here are the top things that could occur. The sun will warm. Yes, it does, but it's so extremely small, it'll take billions of years for the temperature of the sun to change climate any more significantly than it does. It's really the Milankovitch cycles that are doing them. But even when we take the Milankovitch cycles into account, we see sea level rise higher than we would expect. We see ocean temperatures increasing, surface temperatures, atmospheric temperatures. Glaciers are melting beyond what would be done. They should have come to a static, and then we should be beginning a process of moving into another ice age. That's right. We should be moving into another ice age. And yet what's happening is our greenhouse gases are indeed heating up the environment, causing greenhouse gases to continue to warm the planet. So the warming of the planet by the greenhouse gases actually comes at a good time, believe it or not. But we're overdoing it. Now what's happened is we put a little CO2 in the environment, and this heats up the water. But the ocean, as it rises and more humidity is created, that's the culprit. The big culprit, the big CO2, the big greenhouse gas on this Earth is water vapor. Make no mistake, it's water vapor. But we're not going to get rid of the water, so you have to go after those triggers, and that, of course, is methane and CO2 itself. So the bottom line is, we know climate is changing beyond the cycles, and those cycles we call the Milankovitch cycles are due to gravitational forces with other solar system bodies. One wonderful thing about it, of course, is our large moon has really protected us. If our tilt axis was going as crazy as Mars's, think of how that would affect population in terms of the cultures and the movement of those cultures into areas where they would have to live, and the migration. It would be completely different. The slow tilt change has really enabled us to have an uncommonly good climate cycle. And so once again, climate change today is occurring faster than what we can predict through these large Milankovitch cycles. And for more information, visit climate.nasa.gov. Thank you very much.
Wonderful. Thank you very much, Jim, for your wonderful presentation. Do we have any questions from the audience? You? Yeah. Yeah.
Hi, Jim. Can you hear me?
Yes.
Nice. So, hey, Charles. I study also at ISU this year. So, very glad to meet you again and again. And always a pleasure to listen to your presentation. So, basically, my question is about small satellite. You know, at the end of the life, we get rid of them because we burn them into the atmosphere. And you talk about greenhouse gases. That is a critical issue now. And I know there are a lot of studies trying to understand what will be the impact of those satellites that are burned into the atmosphere, because basically they're not disappearing. It's lithium, steel, and others components, like literally rare elements used into the while manufacturing the satellite that are burned into the atmosphere. So basically, the question is, what do you think about the potential impact of that while considering or keeping in mind greenhouse gases
right.
effect?
It's a great question. I got it. I have an impression, but I have to tell you, it's not based on any facts. And that is, I think those kind of things that come in rapidly, as they come in and they deposit material over a wide range of altitudes, that stuff ends up dissipating relatively quickly. Now, I may be wrong. I have seen no modeling. I have seen no analysis that really goes into any details that really would be something important to answer. I think that's a really great little research project to pursue. Now, you have to put it also in context. As the Earth moves around the sun, we fly through old comet tails. We fly through debris left over from asteroids that have been broken apart and are orbiting the sun. And we call those the shooting stars, and the Leonids and the Geminids, and and all these shooting stars. When you take all that material into account, we receive about 100 ton of meteoric material a year. Okay. A day. 100 ton a day. All right. Now, a lot of that has metals in it. So that means just like a satellite, as it would break up and vaporize, you also have that material in the atmosphere. So the Earth is used to that. Our atmosphere has that stuff in it. And that's why I think the satellites would provide a small contribution to that beyond what the meteoric material is already depositing. But that's only a guess.
Thank you, Jim. Do we have any other question from the audience? Yes, we have another one over there.
Back.
At the very end, please.
I'm so sorry. I wish I was there.
Hi, how are you? Can you hear me?
Yes.
Good? Yeah. So I wanted to ask about the calibration of the climate models based on space data, and how often people believe that the simulation model would be wrong and updated. That's one question, because this has been a subject of controversy when people have been denying climate change and saying that the climate models keep changing. That's my first question. My second question about the feedback loops within the system, because everything is integrated, and we see, for example, in Siberia, the permafrost is releasing methane because it's waking up with the heat, and it has more carbon stored than all the carbon currently in the atmosphere. So in that case, would space data help the climate scientists detect and include these inherent small feedback loops within the climate models or not? Thank you.
Yeah, so let me tackle the second question first. Yeah, spacecraft observations are critical to monitor changes. There are changes like the tundra in Siberia, releasing, in particular, methane and other gases like CO2, as you mentioned, that we've modeled, but until it happens, we really don't know how much. And so consequently, as you say, we have a lot to understand, and satellite observations provide us that. Now, one of the critical aspects of the whole climate change modeling is that we're trying to model all the physical processes and run them in a climate model. So how good is the climate model? Well, if you integrated all the data today and you started today with here's what the atmosphere is, what's it going to look like tomorrow, the next day, next year, 10 years, okay? How do you know it's going to predict the right stuff? Well, you do past modeling. You go backwards in time and you check and make sure that the models that you're putting together mathematically and the processes that you're describing then can reproduce past results, starting from a given point. So if it reproduces past results, you've got a good chance for it to be reasonably well correct in the future. Now, I have to tell you, we don't always get it right. This is a complicated system. In the 1990s, Hansen and his group, at Goddard, and I was there when they were doing this, would say that in the 2020s, we should be hotter than we are today. Our average temperature on this Earth should be higher. Wow, it's not. What happened? Well, the Earth responded. The Earth responded with a process that we didn't quite understand. And that process is the explosion of phytoplankton. So phytoplankton eats up CO2, zooplankton come up, eat the phytoplankton, and then die as they go down into the depths, and that takes out CO2 and sequesters it at the bottom of the ocean. And it's significant. Well, who would have thought? So this is also why we need satellite observation, because it was through the satellite observations that we then really basically understood that new process. And that just occurred a couple years ago. So we have a lot to learn about our climate. We have a lot to do to be able to keep our models up to date. But it doesn't mean they're wrong, and it doesn't mean we don't have an understanding of 90% of the problem. And indeed, it tells us we're going through global warming. But I just showed you there'll come a time when we'll be at a larger elliptical distance from the sun, and we should be on the average colder. And if you want to be able to live in Canada and Upper Europe, we're going to have to put CO2 back in to the atmosphere. In other words, for humans to live on this globe the way we are currently living, we will all have to work better together in climate engineering well into the future. So we better get our act together. We better understand how we can work together to ensure a world that enables us to live comfortably in the areas we are and support the huge population of the human species that we have on this globe today.
Wonderful. Thank you, Jim. Do we have any last question? Do we have time for a last question, guys?
I just would like to remind that we're going to have a panel about climate change and Earth observation. So if you'd like to keep these questions, but if you feel urgent, we can address them now.
Okay, we have one last question, Jim.
Sure.
It's me again, and this is a quick one. So do you think we should consider the Carrington effect as a climate-related risk?
Say that again. Do I consider?
Do you think we should consider the Carrington effect as a climate-related risk?
As a climate what?
Climate-related risk. So climate risk.
A climate crisis?
Climate-related risk.
Climate-related.
Climate risk, yeah.
Yeah, I'm not getting the context of the question. Can you rephrase it?
Okay, so basically I'm talking about the Carrington effect, that is like solar flare, and I'm asking if we should consider the Carrington effect as a climate-related risk from your point of view.
Jim, should we
I,
consider the Carrington-like event as a climate
got it.
climate
Yeah, I
risk?
was so I'm concentrating so hard on climate change, I'm forgetting my other hat. I love heliophysics. I've studied the sun. I've written 5 papers on the Carrington event. The Carrington event is indeed another catastrophic event. So if we're thinking about existential threats here on Earth, climate change is one, but there's also another one in the area of heliophysics and what the sun can put out. We have not seen what the sun can really do in terms of putting out really large coronal mass ejections that produce huge currents in our ionosphere that knock out power stations. And if that occurs and we're caught flat-footed and we burn out these major transformers, the globe is going to be largely without electricity for years. Now, I don't know about you, but I can't live without a microwave, okay? But you can imagine not even having any electricity. We'll be shooting squirrels and chopping wood out the back door. We'll be living like we're in the 1850s. Talk about a catastrophe. A significant portion of the world won't be able to survive that. Now, we know what to do to prevent that, but that's another existential threat. Another existential threat are near Earth objects. You know, it turns out we are in a horrible orbit. Who would have thought? We're in a horrible orbit. We have over 1,000 planet killers that cross our orbit. And that means they're going to hit this planet. It's not a matter of if, it's going to be a matter of when. And this is why, you know, the dinosaurs didn't have a space program. And for us to be able to go out, hit an asteroid and move it and be able to, for the very first time, start the process of defending it, because we know we're going to have to do that sometime in the future. You know, so it's really a wonderful time to be alive. We're becoming more space aware. We're becoming more aware of the calamities that could face this Earth and the destruction of life that can occur through these catastrophic events. And we're beginning to get a handle on solutions. And you sitting in the room, you're the future of how we're going to have to use the knowledge we have, grow on that, build on that to defend this planet, not only against those coronal mass ejections and near-Earth objects, but how we can live to work together on this planet and make it, you know, our home base. And we also want to go to Mars and the moon. Okay, so let's not just put all our eggs in one basket. Thank you very much.
Wonderful. Thank you, Jim, so much for your time.
Thank you.
Yeah, and then you are free to go, Jim, to keep enjoying the World Cup.
Thank you, Dr. Jim. Well, as we have seen, like throughout the day, we've seen like ideas about how to go to space, what we can do in space. But right now we have something really different. We're going to do it the other way around. Camilo is going to walk you through the virtual reality world and how to bring space back on Earth.
Okay, wonderful. So if you're still there, then maybe you can just see my presentation. Cool. Give me 1 second. I promise to be super quick, guys. No worries. I think I really just have to move next to the computer because the clipper is not working. So, hi everyone. My name is Camilo Reyes. I'm a space systems engineer, currently working for MetaVisionaries. We are very happy to be here in Morocco, sponsoring this event, and of course, talking about like how the metaverse can bring some capacity building through space to any country, of course, in Africa or anywhere in the world. I will just put this here. Sorry. So he can see you guys. Of course, if my computer wants to help me. So the question is like how companies and communities can, with the current pace of the technology, continue thriving and producing products and services that can help us thrive, right? So basically, we need to be able first. Sorry, we first will be able to adapt. Second, we need to be able to work in any discipline, meaning we need to be interdisciplinary, something related to what ISU is, international, intercultural, and interdisciplinary. We need to adapt that in our way to work. We need to be able to transfer knowledge, because if we don't transfer knowledge, then we are stuck in the past. The way we work in the 21st century, the way we work in the 21st century is we do transfer knowledge in order to keep building community. And then, of course, we need to have access to industry leaders. What does it mean? We need to keep doing networking, not only in our local communities, but we need to do networking everywhere. So how can we do that? We are still lacking connectivity in many places on Earth. According to our study, there are still 2.5 billion people in 2021 that still don't have access to internet. So how can we connect these people? How can we provide connectivity? Of course, then this brings all the discussion about like more satellite constellation, 5G IoT connectivity, using different devices. But let's say we have that. We still lack of the infrastructure. How can we do that? How can we do that? Well, then the metaverse and all the infrastructure that all these new technologies creating can be filled that gap. How do we do that? Well, capacity building. And according to UN, capacity building is a process of developing and strengthening skills. It's not that we don't have the skills, but we need to develop, we need to strengthen those skills, and we need to share them with the world. How, for example, my company does that? Well, we just simply use something that has been used for more than 10, 15 years in the gaming industry. VR, virtual reality, augmented reality. Now we have the extended reality. And of course, because of Facebook branding marketing, they call it the metaverse. So we are using this metaverse technology in order to do that. But what is the metaverse? Well, if you guys are still following me, the metaverse is just basically the term umbrella to talk about augmented reality, extended reality, and virtual reality. Is how we humans interact with internet. Now we are talking about Web 3.0, but we are still using the Web 2.0. So what does it mean, Web 3.0? Just basically living the internet. Right now, we live in we use 2D internet. Well, the metaverse and the Web 3.0 will help us to live the internet. Just basically as we understand this reality, that's how we will be understanding the metaverse. So it's the evolution of the internet. Basically, the metaverse can drive human capacity building. We can have immersive learning through edutainment. What is edutainment, Camilo? It's basically education through entertainment. Guys, your brain, I know you're bored right now because with my words, but your brain needs to get excited in order to learn. When you guys are excited about something, then your neurons create more synapses, and then you're learning. How can we do that? Look, all of us learn mathematics, physics, and chemistry just by following a book. What if we learn chemistry, mathematics, physics, astronomy by seeing how all these processes are performed? So we can use the metaverse to do that. So we need edutainment to create a new capacity building in every country for the new generations that are coming behind us. We need classroom simulations, classroom travels. Imagine learning how like all these migrations on Africa. Imagine what Jim was describing just some minutes ago, how all these climate changes were happening. If you can see it, imagine you being just like having a caipirinha in the Sahara Desert 12,000 years ago, and yet you are experiencing how the climate was changing. That's education at another level. We can transport you guys anywhere. We can basically do gaming to learning. We can basically do a skill-based training with augmented reality and augmented instructors. So basically, the metaverse can help us to achieve the next level of education. And because we love charts and we love to talk about like how this is going to change. Well, basically, guys, the global metaverse market exhibited a raise of 0.7% in 2020 as compared in 2019. Why? Because of the pandemic. We were not able to communicate as the way we are used to. We were not able to go anywhere. We just basically were stuck in the front of our computers, working, receiving education, classes. And like, you guys remember the nightmare of 2020? Well, during that time, people start using streaming services, gaming, the metaverse exploded. And then the metaverse economy will create, by 2030, more than 40,000 jobs. So imagine all this capacity building, like how this is driving the new economy. And of course, I forgot the most important part, the money. The global metaverse market will reach around 758 billion just in 4 years. So imagine how fast that's growing. And I promise this is the last chart. So with economic growth, basically the compound annual growth rate of the metaverse will be 50.70% just in 8 years. But going back to our platform, how do we actually integrate this with a space? Well, the way MetaVisionaries is doing it is just by doing joint ventures with existing space companies. We recently came together with the Space Application Services in Belgium and their child company, IceCubes, to create the Space Innovation Labs. What is a Space Innovation Lab? Well, it's basically a normal lab that you guys seen, but we have access to space. Let's say you guys design a fluid dynamics experiment here at the International University of Rabat. You have a Space Innovation Lab here, and then your Space Innovation Lab is connected to the ISS, to the Space Innovation Lab that Space Applications already has on the ISS. And then we connected using our VR, the normal headsets, Oculus, Quest 2, HoloLens, whatever headset that we have access to. We can see how your experiment is being performed on the ISS. That's just one example of the multiple things that we can do with a Space Innovation Lab. That's how we integrate metaverse technology to space, and that's how we somehow create a space capacity building, not only in our country, let's say Morocco or Saudi Arabia, but anywhere, because we are currently building multiple Space Innovation Labs in different countries. We are currently building 3 Space Innovation Labs in Saudi Arabia. We are also building another Space Innovation Lab in Malta, and maybe, who knows, maybe we'll have the next Space Innovation Lab in Morocco. And what is the great thing about the Space Innovation Labs, guys? That as soon as you have a setup of an SIL here, a setup here, you also have access to the other Space Innovation Labs. So you can also see, interact, and even like do research together with KAUST in Jeddah or the university in Malta. And honestly, we just like do this because the idea is to acquire skills that allow you to develop and thrive in the space economy, because any experiment that you do will thrive in the space economy. I promise I will go super fast because I have too many slides, but the idea, or just let me summarize it super quickly, guys. The idea is that any experiment that you do with the Space Innovation Lab that is connected, for example, with the metaverse, contributes to the global space economy. And not only to the global space economy, to the economy as a whole. Because remember, any research that you do will have a potential to create a startup. Imagine maybe there is some medical students here. Imagine that you want to develop a new drug. What if you create your experiment here, you launch it into space, and then you have a new crystal that can become, I don't know, like a cure for one of the diseases here in Morocco or in Northern Africa. You know, something like that will have a huge impact. Maybe we were talking earlier about Ebola. That will have a huge impact on curing Ebola. So I will just go super fast. This is the team, of course, Jim Green. Our company, I just described it. And I wanted to show you super quickly, guys, something about that we created in MetaVisionaries. Remember the edutainment part? Well, we have a classroom in the metaverse. So this was our classroom. We call it the MetaChip. And this is a talk that I did just a few weeks ago in Saudi Arabia with people that were in Singapore. So basically, that's my avatar. I was talking about the CubeSat revolution, and then you see that CubeSat flying. That's a way to start, to teach how CubeSats are developed, how CubeSats are driving the new space economy. Basically, you guys can have any kind of class on the metaverse. Imagine flying over Dubai Marina with the meta chip. So you're on the classroom, and then suddenly you're over Dubai, and then you're receiving a class on how Dubai thrived during the last 20, 25 years, maybe as a part of a urban planning class. You can have a class on anything about anywhere in the metaverse, right? So just because I want to be mindful of the time, we are creating a space curricula, just to a very tailored space curricula to form the new you guys, basically the people that are wanting to study space, that are coming for different backgrounds. So we are tailoring a space curricula. This is currently being implemented in Saudi Arabia with the Saudi Space Commission. Maybe we can implement it here in Morocco. And finally, you saw Jim Green, how he's very passionate about explaining all these kind of things. Well, we are also creating the Gravity Assist podcast in the metaverse. We hope to launch it next year. Maybe you guys please follow us, stay tuned, because this will also be super fun to hear. And yeah, you have any questions, please feel free to contact us or contact me. I will be here today and tomorrow. And guys, all the people that are on the working group number 1, please get ready for tomorrow. I think the local team sent you like a document that you need to download an app on your computer. Please do so we can have some fun in the meta chip tomorrow. Thank you very much. Hey. Maybe one question. The lady over there.
Maybe this is not okay. Working. One question, please.
The lady over there.
Okay, perfect.
Hello, sir.
Hi. Don't call me
Well,
sir. Call me Camilo. It's fine.
Okay. Well, I thank you for this amazing speech. I'm really impressed by every single word you just said. But basically, I have a small question. Well, as everyone knows, when we just had social media, Instagram, Facebook, WhatsApp, intrapersonal communication begins to disappear.
Yes.
Do you think that introducing such a virtual world will not affect the real life and the interpersonal communication?
I am not a researcher on the metaverse. Like I mean, the people that knows me here from the audience, I'm very outgoing. I'm more like about human interaction. I'm from Colombia, so I'm super huggy. So I know what it means to like the human touch. The answer is yes, but also depends on what kind of measures do we implement. This also, and this is my personal opinion, I'm Camilo Andrés Reyes speaking here. I think it also depends on the family and the community. Like if you isolate yourself from your family and the community doesn't do anything, then we have a problem at the community level, right? If we teach our kids, our people how to use this technology, any technology can be good or bad. My mom is single mother. I didn't meet my dad until I found him on Facebook in 2010. So Facebook is a good tool, but we can also see how Facebook have been used for the wrong purposes. So any technology can be used for good or bad, depending on your intentions. So same for the metaverse. If you see that the people are isolating themselves, it also goes to the core of the community. Why the community is not taking care of these people? We should also set up maybe like a timer or something within the metaverse environment that keeps people out of the environment as soon as the timer is off, because you should be able to go and enjoy the sun, run, and enjoy this part of the metaverse that is called the reality, right? So that's my personal answer.
Sir, don't you think that metaverse should make some, for example, master classes or something, just to give that education you just talk about to maybe people from around the world, so that they can transmit the knowledge to youth? Because actually, we can see that nowadays more and more youth try to just are using the social media and, how you just said, those great technologies in the wrong way. That's why I think that Metaverse should take the initiative to start like some master classes to people, to maybe teachers, professors, doctors around the world, and those people can be can transmit the message and those great knowledge to their students, to their youth.
Absolutely. For example, Jim Green is because Jim is my boss basically. So we work together on creating this space curricula. So he's, for example, part of the professors giving this kind of knowledge on the metaverse. And as I briefly mentioned during my presentation, is like with the metaverse you can simulate anything. Like you can see how the climate change was changing. You can see how the extinction of the dinosaurs. You can see. I mean, I wouldn't it will take me hours to explain what we can do with simulations and then for people to understand, to see. But in fact, that's true. That's one of the last points of my third slide, I think, is like access to global scientists and global researchers so they can give you their knowledge on first hand. So this is the next level of, I don't know, Coursera, something like that. That could be. Yeah, my pleasure. Thank you, guys.
Yes. So MetaVisionaries was our biggest sponsor. So they were our Galaxy sponsor. And we had not only that, but a tremendous effort from Camilo personally. So we would like to thank you as in the name of the organizing team of the 6th African Space Generation Workshop. We would like to give you this. And yeah. Sorry for your luggage. And let's.
Yeah. Thank you very much. Yeah. Thank you.
And of course. Thank you. Thank you for.
So Jim, we are done. You are free to go. So Jim, we close the Zoom now. Okay, have a wonderful afternoon. Bye.
Thank you, Camilo.
No, my pleasure.
So we will proceed now with a panel discussion led by Iman Al-Khantouti on the African Space Agencies, their strategies, vision, and partners. We would like to welcome the Egyptian Space Agency, Dr. Islam Abul Magd, Deputy CEO. Welcome, Doctor. And from the Foundation for Space Development, Mr. Guido Schwarz, New Space and STEM Director. Welcome, Mr. Schwarz. And from the RIS, Mr. Davis Cook from South Africa, CEO of Research Institute for Innovation and Sustainability. Welcome.
Thank you so much, James. Thank you, everyone. I see that the School of Aerospace Engineering of the International University of Rabat is here. Welcome, professors. I'm very proud to see you here as your alumna. Please, a round of applause for them. please come and sit with us, please. We would like to have you here, please. Okay. So the next panel will be about Africa. We have like an amazing panel, once again, of people that are doing a tremendous work for this continent. Decision makers, as Dr. Islam Abul Magd, people that are Africanist, as Mr. Guido Schwartz, and other people that are very, very, very skilled in terms of innovation when it comes to Africa, which is Mr. Davis Cook. So I'll switch, I'll sit. So as mentioned many times today, the African continent is now in a very dynamic industry now. We see a lot of countries are joining the space race. I can mention Angola, for example, that just launched, and many other countries. Morocco, for example, we have a lot of space capacities, starting by Zarqa Yamama, which was the second satellite launched in Africa in 2021, and another constellation. Now, for the time being, an African Space Agency is coming soon, and it's going to be in Cairo. And we're very honored that the African Space Agency is not only in an African country, but also in a North African country and an Arab country like Morocco. So we're very honored for that. So my first question will be to Dr. Islam Abul Magd, which is the Deputy CEO of the Egyptian Space Agency. My first question, as you're someone that have been there in the African industry for a long time now, what is your vision on the space technology in Africa?
Oh, thank you very much. Once again, thank you for your invitation, and I'm very glad to be here with you today with this panelist. And luckily, a couple of days ago, I received Davis in my office, and we explored how to cooperate together from South Africa to North Africa and Egypt. And your question will summarize about nearly now 10 years or 12 years working on space policy and strategy, and how Africa should be in the space arena as an actor, and develop their own capacity, and develop their own resources, and put a vision to resolve our challenges. Africa is a big continent. If you don't know, it's bigger than the United States of America, together with Europe and China and Brazil and New Zealand. Collectively, altogether, 3.2 million square kilometers. This is a huge continent with immense resources that needs to be more monitored and more planned for the future. If you look to the agenda, African Agenda 2063, and how much we are optimistic by 2063 to get a prosperous Africa dependent on African nations, and get higher economy. If you look to the Africa for 2050, the population growth, it will be 2.5 billion, which will be more than a huge percent is the youth. So nearly more than 45 to 50% is youth. So this is why we are looking for the new generation of students. If you look to STISA, Science and Technology Strategy for Africa, and there's a plans for 10 years to improve the STEM schools, the education system, scientific research, science hubs. All these kind of collective together reflect how much Africa is thinking for the future in a different manner. And we put the space as a priority, how much space should play a role in Africa. We got African nations who is already on few steps ahead for space. If you go Algeria, Morocco, Egypt, Kenya, Nigeria, South Africa, Angola, Ghana, Uganda, Ethiopia. All these countries start to take steps forward to to space. So we are very optimistic for the African Space Agency to develop the capacity, to develop the resources, to learn from our partners in Europe how to make it effective for facing our challenges. It's hosted in Africa, but it's for African Union, for the whole member states. There is a kind of organizational structure that how it would work. And we already took the advice, and we will work in a phases. We will start and grow up. We cannot start as a big, but at least we lean on the capacity in South Africa and how we make and dedicate specific mission and specific specialization to specific country. So we got a Kenya, there's a launching pad over there, and how to get our support from Kenya Space Agents to launch from Kenya. We got CSIR, how much they are strong in radar and SAR technology and how to use in SAR like you are doing in Italy. So all this are bring in mind, and all the technical and scientific working group from Africa who developed this one were actually made a lot of efforts in the years just to put this plan collective and made. We optimistic, and we look forward to you and all the youth to make a momentum growth for African space in Africa. Thank you.
Doctor, we will make you proud. I promise. So, that being said, we can see that the African continent is very big, and we have all the resources, geographically speaking. We have the youth. We have a lot of countries. We have a lot of cultures. We have a lot of skills. We have a lot of youth, once again. So that's the reason why it's important to include STEM and new space. So my next question is for you, Guido, which is, how can the new space and STEM help in the development and the strengthening of the space strategies of the continent?
Yeah, thank you very much also for the great event here. Pleasure being with you. I think it is already helping. Let's start like that. I mean, if you're looking into STEM, there is a lot of activities across the continent, from a grassroots level to university. I mean, look at yourself. There is a lot of companies existing today who entirely operating on a new space level. So what I always find extremely impressive is that Africa has much more new space activities than Europe. Maria Gabriela, I think, was saying it today. Africa should learn from Europe, but not in a way that you're adapting or that you're copying, but that you learn from the mistakes. Because there's so much activities and so much esteem on the continent and all those kind of activities that you can bring it on the next level. I like the first question. I would like to come back to this for a second. I think you were asking for what technology in space means for Africa. And everyone who has been to the cinemas recently, I think currently there's only one word for this. It's Wakanda. So why not dreaming a little bit? Why not looking into what could be possible instead of what can we do? Because there is a lot of opportunities. I mean, you have mentioned it. There is a launch pad that was used in the 60s already. Imagine 60 years ago. Did you know the first rocket ever tested for the European Union? That was done in Algeria, also in the 60s. So there has been already a path developed that was not constantly maybe followed, but the world has changed. We're in 2022. We're going into the cinemas, we're seeing flying vehicles that fly from New York to Kenya, and it looks like an hour or less. So I think new space is here already. It has just to be more displayed. It has to be promoted, and it has to be embedded together with STEM, because due to STEM, you're going to get those people to take the challenge of becoming an entrepreneur and creating a company and doing commercial space, not just institutional.
Thank you so much. So with that being said, also, my next question is to Mr. Davis Cook. And as you call it, the orbital divide. So how can the private sector help ensure an Africa without an orbital divide?
Thank you. So, I mean, firstly, it is a pleasure to be here, and it's also been a great opportunity to meet people in person that you've been talking to for a long time remotely. And I think this is a great opportunity to discuss kind of some of these issues. So maybe just to sort of expand a little bit on this idea of an orbital divide, which is that, one of the speakers earlier was talking about a digital divide, and people who have access to the internet or not have access to the internet. And that has implications for the way that you participate in society in future. And I think that there is a very real, a world in future that I don't want us to go to, in which access to space, access to the benefits from space technology, cislunar technologies, all this kind of stuff are controlled or governed by people outside of Africa, and where we don't have our own ability to access those things on our own terms. And if we are not able to create our own pathways into space, it means that we will always have to meet the expectations of others in this process. And I think that this is a really important challenge to overcome. Now, I think one of the things that we've been talking about is, ideas about new space and kind of creating this new vision. Another speaker earlier used the kind of phrase leapfrogging. And I think one of the important things to ask is, like, why has Africa been able to leapfrog in various technologies, whether it's banking or telecommunications? Like, we keep hearing about like why we've been able to do this, but like, what is the reason for that? And I think a big reason is that because Africa has not necessarily had, and this is a bit of a generalization, but because it hasn't had incumbent organizations and institutions, we are able to create new organizations. So because we didn't have extensive copper cabling for phones across the continent, there weren't existing corporates preventing the creation of mobile technology. The same kind of ideas apply in banking. And I think a really important application is in space. Africa doesn't have incumbent large space programs, but we can build our own and build our own entrepreneurs that kind of drive our own future in that way that we choose.
Thank you so much, Davis. So you talked about how important it is to get to a more sustainable African space industry. So my next question will be to Dr. Islam about how to incorporate a sort of sustainable supply chain for services, for satellite services such as Earth observation, to meet our challenges in Africa and achieve the Agenda 2063.
I think one of the first reaction of space technology we always look in Africa is the Earth observation and how the Earth observation or satellite imagery could react and respond to our challenges. And I think one of the partnerships was Europe as a continental flagship of GEMS in Africa. I don't know, I heard you this morning that someone is here. And this how the Copernicus and the free data access coming from Europe played a role for such Earth observation meeting challenges. But this is critical. However, it played a role and make awareness and supported a lot of projects and data. But you still need your own data. You still need your own real-time data that supports your challenges. I think this is the approach we are trying to constellate satellites from Africa between African space nations on how to jointly use MCC's receiving station or control station to constellate together. How to make exchange of data and make data sharing policies between the African space nation. I think this is one of the critical issues that we have to work together to ensure the data availability on time, the data availability meets our needs, the data availability is shared and they provide a solution to challenges. And Africa as a big continent, the challenges in different regions different. So you need to have such a data that meets such challenges. We do have water resources problem, north and south, energy problem in north and south. We do have a lot of waste problem in climate change and vessels of fishermen and fishing. We have a lot of challenges that different. We might share something, but still it's different that needs specific data with the specific specifications that meets this challenge. So the approach is how the African Space Agency would coordinate such data availability, data constellation between African space nations to make the data available, to knowledge available, the service available. This is quite important to make the service providing like Copernicus. If we got Copernicus, provide data services ready-made for the stakeholders and end users, we have to make something similar that meets the stakeholders' needs and expectations.
Thank you so much, Dr. Olmert. It's indeed important to ensure a very maybe near real-time data supply for the African continent, even if it's a very, very, very big continent. So it's not. It's sometimes it's impossible to have data. It is challenging, but not impossible. Yes, so sorry. And so that after that I would like to ask Guido about, according to him, how can the governmental agencies learn from the private sector in the space industry, and how can the governmental agencies from Africa better support the space industry in the continents, like for especially for such problematics of near time, for example, in EO in Earth observation services, or beyond that?
Learning is always a two-way street, hopefully. So there is no doubt that public administration can learn from industry, but I think it is the same the other way around, because otherwise we would live all in a perfect, what was it, metaverse, right? So I think at the end of the day, what should be considered, and we have heard this today, what I really like was the dinosaurs were no spacefaring nation. I think I was recently reading that scientists think now that dinosaurs actually had two brains. One for the body, because it was just so massive, and the second one that they were eating. Still, they got distinguished. So I think we all have to learn. Collaborations are key at the end of the day. We have seen today the Glory 7 and Hercules, for instance, who were trying to make a difference in their time. Now is the time to see how public-private partnerships can work. And if they don't work, then how industry can actually bring this forward. I always think that South Africa is an extremely good example for that. There is on the one side public administration, which is looking into aspects like Earth observations, for instance, or let's call it remote sensing in general. And on the other side, you have private industry, which is completely focusing on creating value for its customers. And the customer is not the South African Space Agency or government, only very rarely. So they're working in parallel, but still together. They have a common goal because they want to bring space forward. What I see is, and you were mentioning this with leapfrogging, Africa and various countries have been leapfrogging in various technology domains. So why shouldn't space be one of them? So we're seeing this at the moment in aviation very strongly, but the discussions also starting now in space. There was a massive article now, and I don't know who has followed it, but there was the ministerial conference taking place in Europe. And the big networks came up with articles about what environmental impact space actually has on our planet. I can tell you 5 years ago, no one was even thinking that much about it. So now it's different. So when African countries now going stronger into space, as they're doing today, and they're doing it in a pan-African approach, the zeitgeist today is to be environmentally friendly, to do sustainable activities. And I think this is what we then can learn from each other, the institutions from industry and vice versa, that the institutions doing, and you have mentioned it today, the necessary policies, creating the framework, and that industry is following suit and is creating the solutions that actually green space is possible and applied, not just talked about.
Thank you, Guido. So my next question will be for Davis. As the Research Institute for Innovation and Sustainability is working with corporates, government services, and startups. So my question will be about what strategy can be opted from the existing space agencies in Africa and the governmental actors to create a more sustainable space governance in the continent.
Thank you. So I think it's a really well-timed question because there are a number of pan-African policies that are coming into play. So we have the African Space Agency. There's the establishment of the African Free Trade Agreement. All of a sudden we're seeing, and this is partly to what Dr. Islam was saying, we have these competencies in different parts of the continent. We have the ability to promote free trade across these different areas. We have an agency that is able to help coordinate some level of industry interactions. And I think that the part of the thinking that we need to move towards is how do we start creating more of the spend that we have on space in Africa, which, you know, the recent Space in Africa report put it at on the order of $20 billion, to redirect more of that into African activities. And that doesn't mean not working in an international kind of environment, because that's simply not how the world works. But it's understanding how we can localize things that make sense for us to localize, benefiting from these kind of local areas of expertise and allowing our different industries to develop further. And so I think that this is part of like really where there can be a fantastic interaction between private sector, between national and multilateral organizations within Africa, between academia, because many of the universities already have strong partnerships. So to connect up through these different sectors, I think is an enormous opportunity for us to explore.
Thank you so much, Davis. So this is the last question for each one of the panelists. As the theme of our event is A Space for Africa for a More Prosperous Continent. And we want to talk about prosperity. We talk also about like the Agenda 2063 of Africa. So my question now will be to Dr. Islam. And my question is, in few words, how can Egyptian Space Agency help the African Space Agency to achieve those goals?
Oh, thank you very much. I think not only the Egyptian Space Agency will support the African Space Agency, I think all the African Space agencies, nations, on a national level will support it, but Egypt will support a lot. This is why we offered to host it in Cairo. Actually, we will available all resources. Our resources and assets will be available. We have an AITC, an assembly and integration testing facility that up to 1,000 kg, which all the medium-sized satellite will be available to be assembled and integrated and tested. And our AITC facility, we have our own labs, mechanical labs and optical labs that would support. We do have human capacity and training, and we started already to launch a training to African engineers. The first tranche will start 12th of December this year for 20 engineers from about 10 African member states. Every member state will provide 2 engineers. And we plan to make it regular. I ask you to send to me the database for the African Generation Space Working Group to get try to play with a diplomat, because it goes through the diplomatic channels via the embassies. But this could be played in two different sides of the coins. So this training is quite available to leverage the capacity for African engineers. We already made a space key kit for educational satellites. We made this exercise with universities. And I spoke with Davis how using such a network to spread it over into Africa. We got a platform for online training like Coursera, which would be accessible. Our receiving station and MCC is available for cooperation. We got a partnership and the cooperation with a lot of African member states and European member states who will play a role for such, like BST and Germany, and we signed with Portugal Space Agency yesterday. So I think all these kind of facilities and open mind and change the mindset of how to cooperate, this will support a lot for leveraging and supporting the space in Africa. Earth observation services, we do a lot of center for Earth observation data analysis and make regional services for the region on national level and regional level. All these kind from the Egyptian Space Agency would support the kickoff and implementation for the African Space Agency. And I believe such a partnership would create a different vision for the African Space Agency. We collaboratively make a 6U satellite with 5 member states from Africa. This will be launched in Q3 next year. Will be launched Q3 for 2024. The 6U satellite will be between 5 member states, African member states, and Egypt, and its target the climate change mission. So a lot of things we are trying to do to support and try to make the space in Africa starts as we thought about. Thank you.
I would just like to congratulate you for all these efforts. I have been following the Egyptian Space Agency from very close, and I'm astonished by all the things that you are doing there. And thank you so much for the offer for the engineers from the SJC. We would make sure to talk about that more about with the African region of SJC. It's an incredible opportunity. Thank you so much for announcing it today here and for choosing. Okay, so don't worry about it. I didn't hear anything. So thank you so much, Dr. Islam. And now I will go to Guido. In few words, how can space companies, especially new space and STEM-related programs, help achieve a more prosperous continent?
By employing more people. I mean, just create a company yourself. What are you waiting for? I was just in a very remote area in Germany. They were waiting now since 30 years, ever since the reunification took place, that the big corporates of Germany realizing how cool this area is with all this infrastructure that was implemented, like billions and billions of euros were going into this. And I can tell you no one came. So they decided 2-3 years ago, they don't want to wait anymore. Now they're heavily investing, instead of attracting corporates, into startups. They're going to give startups the money rather and help them to build up their business so that they can employ new people. I would recommend that would be exactly the same here. Look into new space. All the agencies want to have more commercialization in space. So that's the big chance of Africa, because Africa is commercialization at the end of the day.
Thank you so much. Indeed, the commercial sector is as important as the governmental sector. So, and to have a more dynamic Africa in terms of economic side, we need more and more startups. So my last question is to Davis, and I would like to ask you about how can space agencies, along with the startups, help together achieve a more prosperous continent?
Thank you. I think that one of the puzzle pieces that is missing from our industries is speaking to people beyond just science and engineering. It's about finding stories and narratives that excite people, that get them to want to learn about space and go into space. I think that, everyone in the world knows about NASA, right? It's a PR success story, and it is exciting. Like who doesn't, as a child, have at some point wanted to go work for NASA, right? Even whether you were an engineer or a scientist or not. How do we create that same passion about pursuing space in our countries so that people say, I wish I worked for the Egyptian Space Agency or the South African Space Agency or the Kenyan Space Agency. Now, when you say to them, I work for the South African Space Agency, their first reaction is, we have a space agency? Like, this is the common refrain. And I think that talking about the success stories, startups, governments, we have the ability to change that narrative. And I think that if we can change people's minds, I think that that will encourage people to move into the sector, and that will create a real kind of success story down the line.
Thank you so much, Davis. I'll go there. So, thank you so much. Please give a round of applause to this incredible panel that I very much enjoyed myself. And I'll let the floor to Serhan for the rest. Thank you.
Well, thank you for your nice words and these inspiring stories. If we're not the first to do something, maybe we can do it better. And yes, Africa can do better. So we would like to move to the next panel about the Earth observation and climate change and the use of space capacities for prosperity. So we're kind of revolving like around the same topic, but we'd like to have insight from people who are working directly with whether private sector or governments. So I'd like to welcome Mr. Athanilson Tucker Kachin Jumba, also Mr. Kilian Oosterhout, also Mr. Pascal Leguet, and last but not least, Mr. Tristan, also we have our dear speaker, Dr. Eric Smith, talking about James Webb Telescope. It might be surprising, Earth observation of the universe, but yeah, we might have something from that. So stay tuned, and let's start our session. We need the seat. No, it's. Let's start with presenting our dear panelists. I have our youngest representative and source of inspiration for all of you young guys. So Mr. Athanilson Tucker from the Angolan Space Agency. He works with all unmanned flight vehicles, Earth observation, data visualization. Then I would like to talk about Kilian Oosterhout. He's the Business Development Associate for Planet Labs. If you know Planet Labs, they're also having huge portfolio of applications that serve and bring in data and access in a very easy way to their end users. Mr. Tristan Laurent, the co-founder and CEO of Absolute Sensing. Again, like remote sensing, Earth observation, but the keyword here is methane and its impact on the environment. I have, again, Mr. Major General Pascal Leguay, so French Air Force. You've seen the portfolio of his previous, his career and geography, imagery, international relations, security issues, and our amazing speaker about the James Webb Space Telescope, Dr. Eric Smith. I'm really, like, personally really curious to hear what James Webb Telescope can teach us about Earth. So let's have an insight first from the industry representatives or those who work closely with data. And I'd like to start with Atta Nilsson. So I'll go straight to the point. Like, how does Earth observation help you in the development? We know, like, that you worked in cases of drought severity. How does this data and visualization serve you for the creation of these kind of maps and giving insight to users, to government, decision makers, and so on?
Can you repeat the questions? Sorry.
Yeah, I went straight to the drought severity issue. So can you give us like a quick overview about your experience with manipulating data acquisition, visualization, and so on, and how do you extract the insight from it?
All right. So firstly, I'd like to say thanks. I'm very humbled and honored to be here. To your question, in Earth observation can help us to solve many issues that we face. As far as drought is concerned, we can use Earth observation to monitor all the stage of drought. Usually, as we know, drought starts with something that we call meteorological drought. In other words, we have low precipitation or we have lack of rainfall. And we can use satellite data like satellite precipitation data from General Precipitation Measurement Satellite, for example, and other weather satellites to acquire precipitation data and be able to tell if we might have an issue with precipitation. And then when we have long periods of lack of rain, we go to something that we call agricultural droughts, when we pretty much don't have enough water for subsistence or we don't have enough water for agricultural practice. And this is usually characterized by the dying of the vegetation. And with satellite images, we can monitor the vegetation. We can tell whether the vegetation is healthy or not. For example, we can use as a satellite, Sentinel or Landsat, and I'm quite sure Planet also has multispectral satellites. So we do a combination of different satellite image, different band of electromagnetic spectrum, and we create these indices that allow us to monitor the vegetation. I'm sorry if I'm being too technical. Yeah, and when we have this long period of lack of precipitation, we arrive to hydrological drought, and we can use satellites like SMAP, which is soil moisture active and passive, to monitor the soil moisture and tell if we are if we don't have enough water within the soil. So we can pretty much use all this data and create severity maps to tell which region are more affected by drought.
Thank you. Well, before getting to that level of being able to manipulate data and draw insights, I go to ask a question to Killian. you also work with data. So how can data be used for education and research and preparing like the future profiles that will be easily hired, highly qualified, and like go straight to the point and answer the need of their whether companies where they work, or even if they have just an individual projects by their own.
Okay, hello. So the question was more about how do we actually obtain this data?
No, like how space data can be used for education and research for non-commercial cases. Like we know that commercial cases are, it's easy to implement. You have a budget, but for non-commercial cases, not lucrative, for humanitarian missions, for our consciousness as universal citizens to take actions and use what we have available.
Okay, I understand the question. First of all, thanks for having us here. For those of you who don't know Planet, it's an Earth observation company. We have over 200 satellites in orbit. We're the largest. We have the largest constellation of commercial satellites, Earth observation satellites. But of course, it's important to not just look at commercial. I mean, this data that's coming down every day, which to give a perspective is around 30 terabytes of data every day. We've imaged every point on the Earth at this point around 1,700 times. So it's a lot of data. And of course, we are a commercial company. I mean, we went public last year, and there's, of course, that area. But there's a lot that could be done in education and research. One recent example is the NICFI program. So this is the Norwegian International Climate and Forest Initiative. This was launched in 2020. It's a collaboration between the Norwegian government, KSAT, us, as well as Airbus, which is oftentimes a competitor, but can also be a partner, especially when it comes to education and research. To give a perspective, okay, right now, as you know, the World Cup is happening. My team is actually playing right now, so thinking about that as well. But to put in perspective, every 6 seconds, somewhere in the world right now, a football pitch-sized area of tropical forest is being cut down. So you can add that up over this entire time that I've been talking, or that this panel or the day has been happening. You can see there's a huge issue. Of course, if you just limit this to commercial providers, this data, which is coming every day, you are limiting all the people that could potentially use this who may not have the budget for it, or maybe looking at it in terms of an educational perspective. And so the NICFI program was created to provide open access to the entire tropical zone, forest zone of the entire world. And it's free to use for anybody for an educational research perspective. And many, many papers are coming out of this. And actually, if you go to planet.com/science, you'll be able to see a lot more cases of using this data, not necessarily for commercial, because we think that's also very important. I think there's a lot of university students here. Just going to little plug here. You can get 5,000 square kilometers of data for free right now on Planet's platform. A lot of people don't know this, and it's something we're continually trying to build. So I think there's a lot that could be done also outside of commercial.
Thank you, Kylian. Well, Mr. Tristan, like you've heard like that, what Kylian just said, like about these constellations, these highly revisit time, short revisit time, real-time data. So when I look back at the early days of Earth observation, like from when cameras were in balloons and then the canister dropped back on Earth, it took like so long before getting data to the end user. Now we can have real-time monitoring, and this can be very useful for risk mitigation, environmental catastrophes. And Mr. Tristan, in absolute sense, in their more focused, or they like to highlight, given the danger of methane, it's 20 times more dangerous than CO2, if I'm not wrong. It has more effect than CO2. Well, I leave you like, how can real-time tracking of greenhouse gases mitigate the danger of these environmental disasters?
Sure. Yes. Well, thank you very much for having me. And so, yeah, to comment on what you just said, we talk a lot about the CO2 when we talk about global warming, but methane has been left aside for a very long time. It's been only in recent times, about say 2 to 3 years ago, that really became obvious to the community, both scientific community and the political community that methane was in fact something that needed to be monitored on a constant basis in order to have an impact on controlling global warming. And so, as you said, methane has 23 times the heat trapping capability of CO2. So it is a short-term lever that we have at our disposal if we want to combat global warming. And so this is really our mission at Absolute Sensing. We're focusing on deploying a constellation of microsatellites. It's going to be 24 of them in the first generation, specifically looking at methane. And it's you have kind of two different approaches of way of approaching the problem. You can approach it at a global level, and this is what all of the reference missions, the big NASA, ESA, the Copernicus program, and so forth are working on, which is deploying big satellites that monitor on a global and a country scale basis methane. Sentinel-5P being one of them. But then there is the need for local detection and quantification. If you want to go a step beyond and say that you want to have a system that's able to say who is emitting, and then eventually perhaps going ahead and taxing back bad behavior. So at least putting something in place so that there is an incentive for economic operators to produce less methane. So this is what we're about. We're really looking at local scale detection. And the problem with industrial methane is that the leaks are extremely, they're really low rate. So we're talking about less than 50 kilo emitted into the atmosphere an hour, and that's 60% plus of the global oil and gas industry emissions. So up until now, there's been good progress made by folks like GAGSat on getting to roughly 100 kilo threshold. So everything that's above can be mapped. But really what's needed is to decrease this threshold to a point where we can really look at, have the full picture. So this is what we're working on alongside a couple of others. Planet is also involved in a similar initiative. And I think that it's, as I said, extremely important moving forward.
Thank you. Keep taking note of these numbers because Africa is growing and the demand for energy, it's not gonna dwindle. So we will have to produce more energy, and this might mean like catastrophes that we need to mitigate right away, very quickly. So I will move to a topic which is completely, indirectly related to Earth observation. So Dr. Smith, what can the role of, what role does the space observatories and the study other planets and cosmological events teach us about the multiple scenarios in which our planet might evolve?
That's actually a great question, and it's one that we're only going to be learning about in the next few years. As you all know here, we have precisely an example of one for a habitable planet with an Earth-like atmosphere. And we know we're just beginning to see how we are affecting it. It would be great to have a laboratory where you could run experiments, or even better yet, have the universe run experiments for you. And that's where Webb data will be adding to this study in the next few years. We've already seen, including one that was just released this week, the type of data, the quality of data that we can learn about these exo-atmospheres, alien worlds. And I believe that with Webb's lifetime extension and the current predictions for the number of habitable zone planets we might see, there's a possibility that there may be hundreds of Earth analog, or at least 100 Earth analog atmospheres to study. So there's the universe's laboratory to see how atmospheres can evolve if they're around sun-like stars with a habitable zone. So we can't say anything directly with Webb. In fact, we can't even look at Earth with Webb. That would be a bad day for us. But we can hope to learn how the universe experiments with these kinds of planets.
All right, so thanks. And one more thing is, not directly Earth observation or what we put in orbit, but while the design and development of James Webb Space Telescope, like the size of James Webb Telescope was double almost double Hubble telescope and almost half the not the price, but the weight. So, and these practices, these lean practices being more efficient, more, we can translate them to, can we translate them to other domains? Can they benefit prosperity and efficiency on Earth?
Sure. This is the, I guess many people call this like the spin-off question. What can spin off of the technology that had to be developed for this particular mission? And there are some that are already in the public sector benefiting people on almost daily basis. The one that often gets cited is the technology that we had to use to measure our mirrors as we were polishing them in Huntsville, Alabama, is now commercially available, and people who go to get their eyes measured, the surface of their eyes measured for later surgery, or if you're getting LASIK procedure done, that same technology is used. So that's probably the biggest commercial success. We also had a lot of the detector technology that we developed for our near-infrared detectors was used and built upon for later telescopes. And those same infrared detectors could be used for Earth-looking satellites too, if they chose to. And then another interesting technology that was developed and is now being commercialized relates to the very small stepper motors, nanometer resolution stepper motors that we used to control the mirrors. That's now become a commercial company for in electronics manufacturing. So sometimes even it goes a place you don't expect. And that's another great benefit of these programs.
Thank you so much. Now the turn comes for Major General Pascal Huguet. Well, when we talk about sustainable development goals, these cannot be achieved without territorial stability, without feeling peace, and the military is playing a major role in this, and also especially like the early frontline with disasters, with like actions that require quick response. How does ESA support like African countries, or maybe other countries, or maybe just itself, and we can learn from it? How can we keep this regional stability to follow our sustainable development goals in peace?
Yes, so a very important question. Thanks a lot to ask the question. In fact, it's a general approach. We consider at ESA level the fact that what is important, what our Director General is regularly saying, is to take the pulse of our planet. In other words, to monitor the health of our planet in order to warn decision makers, for them to take to act and to take the important decisions. It's not easy. So ESA is mainly a role to inform, and we have a long list of parameters, settings that we are monitoring. So we have temperature, we have the wind, we have salinity, ocean salinity, we have various ice evolution, for instance, or magnetic fields as well, we follow, etc. And we extensively mentioned the Copernicus system to do that. But not only. We have also, in terms of meteorology, we are using the Meteosat satellites, but this is the old generation. We have now the METOP, and ESA is working on the new generation of METOP. Also, this meteorological dimension is very important. And we have a long list of systems in the science field with the poetic names. We have EarthScare, for instance, to follow cloud aerosol radiation. We have Aeolus for the wind mission. We have also this Cryosat for ice mission. We have biomass for the forest, etc. Just to say that if we have the capacity to monitor, if we don't have the action afterwards, there is not a full picture. We cannot obtain concrete achievements.
Okay, thank you. So first, like we need to know what to have we don't know what we don't know. If you don't have data, you don't have insight, and you will always take wrong decisions. That's for sure. And I think we have taken so much time for us, like organizing team and moderators, to ask questions. And now I would like to give more time to our audience, maybe to talk about the role of space situational awareness in like allowing us to use space capabilities for prosperity, or ask whatever question you have. The floor is yours, and our speakers are here for you.
Thank you very much. Salahuddin Qaba from Eagle AI, our startup working on environmental monitoring by remote sensing data and machine learning. My question is about monitoring air pollution with the general Earth observation satellite. As you say, we have S5P tropomid satellite with the higher the resolution of I think between 7 and 8 square kilometers. My question is if we have best resolution at commercial satellite for doing the monitoring of greenhouse gas or combustion gas or PM 2.5 or PM 10. So if we have best another resolution, and if the results, the data given by this type of satellite is confirmed by in situ analysis, and how we can use this data, this raw data, to do a best prediction or a best monitoring. We use ML or other techniques to get more reliable data in the Earth. Thank you.
Okay, I think the question was directed to me, so I'll give it a shot, and maybe my colleagues can complement. So yeah, I think that there are a bundle of questions there. First, so you're right, Sentinel-5P already does a very good job at atmospheric composition measurement. However, it's as you said, it's not designed for a local measurement. And when in the case of greenhouse gas, it's not as easy as say optical satellites, where you typically talk in terms of spatial resolution, and the spatial resolution directly correlates with the value of the data. It's not the case with when you look at atmospheric composition. The spatial resolution doesn't necessarily mean, so a very low spatial resolution, say sub-meter, doesn't necessarily mean you're going to have a higher chance of neither detecting nor quantifying air pollution or methane in that case. What's really important is your radiometric and your spectral resolution. That's the key. That's what's optimized for. So in our case, it's a 50-meter GSD, because it was really the sweet spot. We initially started off at a 10-meter GSD, but doing an analysis, we discovered that actually it's better to have a higher spatial resolution. Now, on the subject of how do you then go from kind of sensor design to actually then making sure that your data does what the end user community wants to. We're following a CalVal strategy, so calibration and validation strategy, following the reference mission. So we're working hand in hand with the Copernicus program and Scientific User in Europe, in our case, to make sure that the way we are calibrating the satellite in orbit and also on the ground is kind of similar. It's the same tools as those used for the reference missions. And machine learning is a big part of it. So everything that goes from getting technical, but L0 to L2 data processing chain is very much something where you need to understand the geophysics of it. So what happens at a physical level, so that you understand how to measure things. But then once you're at the L2 level, an L2 data product for greenhouse gas is a nice map. So you see the map, and if it's red, it means high concentration of methane, and so there is a problem. If it's green, it means you're okay. But going from that L2 concentration map into actual emission rates, this is where machine learning becomes extremely important. And what we're doing is we're working with a couple of folks into combining our data with other data, such as Sentinel-5P, so that we get a model, a reinforcement learning models that gets the right performance.
We can also need the other ancillary data.
Yeah, absolutely. Well, then it becomes more of a ConOps thing. So you can in our architecture, what we're currently looking at is how we can go from a Sentinel-5P, regional detection service that then says, oh, there is something happening, say in the Permian Basin, northeast of the Permian Basin, and then we're able to task our satellite to actually go in specifically look at that hotspot, and then the ConOps can move along and go up to drones and actually having folks deploy drones on the specific facility, or just in situ measurement on the specific facility to confirm that. So it's kind of you can view it in several ways.
Thank you.
Thank you so much. It was a perfect answer. The fact that usually we focus on the spatial resolution of a system, but we have a long list of elements to consider this, as you said, and also an important one is the time revisit. And you mentioned the fact that we need a permanence or even a persistence of the systems, and to combine satellites with drones or ground sensor is very important as well. And you have another parameter, I don't know the expression in English, the fonction de transfert de modulation de contraste, the capacity of a sensor to a dot on the ground is on the picture is a dot more or less large. I don't know how to explain that, but it's a technical aspect. But not only spatial resolution, it's important to mention it, yes.
Yeah, I just would like to add something important. When we are monitoring like global process like air pollution and deforestation, we don't exactly need high resolution satellite image. High resolution satellite image are more useful when we are monitoring, let's say, specific objects on Earth. Let's say when we are monitoring, let's say, road construction or a building construction, that's when we need high resolution satellite image.
Yes, in fact, it's not the capacity of the sensor. What is important is the need we want to meet. And for instance, so the commercial providers are focusing on this 30 centimeter resolution, optical resolution. It's fantastic, etc. But for instance, when we monitor the proliferation facilities, we don't need 30 centimeter. We have to follow the big infrastructures, and we need a 3 meter or 5 meters. So the need is the fundamental aspect to consider, and we select the proper system depending on the need you have to consider.
I also have a question, actually, just came to my mind. Like, my dream is to see Earth observation being used the same way we see social media is used nowadays. Like very ubiquitous everywhere. Everyone is using it. But we know that there are a lot of satellites. We have a huge amount of data that is being downlinked every day, every hour, but most of it is not exploited. Most of it is just, it goes to waste, and we need experts to do that, or maybe developing algorithms which are really smart in drawing patterns. But can we maybe work on the user engagement model, how to get the interest of anyone, maybe just kids?
Yeah, I can. Was that just a general question, I guess?
General question, yeah.
One thing you mentioned about making it ubiquitous, I think that's very true. I was mentioning before about just how much data is coming just from our constellation, and there are plenty of other constellations as well. Oftentimes, you'll find the people that may really need this data. For example, in rural communities where their agriculture forms a high part of the GDP, they may not have, farmers may not have, first of all, access to this data. That's one thing. They may not know it exists. They may not, even if they had access to the data, actually getting use out of it. And it was mentioned already, the need is really the most important thing. I mean, the data is one thing, but of course, if no one can use it, that also defeats the purpose. You said engaging kids. Okay, that's something a little bit different then, of course. And that has to start, education and outreach, of which there's a lot of programs, and NASA, of course, works on a lot as well. But I think the challenge really is also figuring out ways to work with local and regional governments to find a way for them to also help engage the communities, because it's hard for any one company to do all of this at once. I mean, think of all the countries that are there, all the millions, hundreds of millions of people that could use this data, but just don't have access to it right now. I'm not saying I have the solution to it, but it's just something that needs to be thought about maybe a bit more.
Thank you. We would really love to see solutions for local problems by local people, having this global effect, because problems usually occur at a local level, but they have a huge impact everywhere else. So, yes.
Thank you for that insight. I would actually have a question because, there's so many students and so many people who are keen about space and even more about the continent. I really like what Planet is doing, by the way. I think it's cool what you do, and you have brought a lot of dynamic into the market. But the question would go to all of you. What would you recommend to young people who are very close to graduating, who want to work in space, who want to work with Earth observation or in Earth observation activities? However, realizing that there is, in Africa itself, no data available. They always have to go somewhere else to get those data. Sometimes they have to pay for it. Sometimes they're going to get it for free. But they would like to see that they have data available on their own, I think it was terms, right? On their own terms. Also develop something around Earth observation, because at the end, what you need for Earth observation, that's satellites. If you get data for free to a certain extent, why should you go for an African company that is asking for money, that has a price tag? So my question would be, what would you recommend the future space employees, how they can actually make sure that there will be an industry for them existing related to Earth observation? Thank you.
All right. So firstly, for me, I would say to them that Earth observation data and those resources are not just for scientists and people who work with space. We have a lot of free available satellite data, and it is there for them to take advantage of. For example, we do have free available satellite data from ESA, NASA, and we also have free available tools to process this data, like QGIS. And in addition with that, we also have a lot of training material, which is free available as well. For example, NASA, they have the ARSET program. ESA, they have a lot of training through RAS Copernicus program. And I just learned that Planet also has a lot of education material. So if you combine those three components, you can actually make a product or service using Earth observation that can be helpful to your society and also to yourself as well.
Yeah, I'll just quickly comment on that. I was speaking before, I don't want to speak too long. I think there's two main topics here. So first of all, as I mentioned, Planet specifically covers 99% of Earth's landmass every day. Okay, there's a lot of figures you can find online. But it really ultimately results in who's actually going to use this data. And of course, there's other things to consider, like cloud cover. But specifically is, the data will go to a specific use case. Someone actually needs to want to use this data for something. And those educational materials, are often there already. And as mentioned, there's also free services available, but oftentimes people aren't even aware that this is possible, one. And second of all, even if they are aware, they may not even have access to it. Okay, I'm not going to speak too long because I've been already speaking enough.
Maybe just just to give a feedback on that, to make it a bit more maybe tangible for you. This morning I was staying in my hotel and we're looking for a way to come here. So my French is very poor. I'm super sorry for that. My Arabic is even non-existing. So I asked the guy at the reception desk how best I could actually come to the International University of Rabat. He said, you can, sorry, I have to look again. You can use an app. It's called Karim. I'm sure you know it. So I said, okay, that's super. Thank you very much for that. So I installed Karim. So I booked myself a taxi to come here. So I was supposed to put my credit card data in there because otherwise Karim is not working. So if I would have now imagined outside there is a car staying for free, I can just jump in and this drives me everywhere. Why should I use Karim?
Okay, I was hearing more of a comment than a following question, but just to complement what's been said there, I think first to those that are in the audience, do what you love. You know, that's the most important beyond business models and so forth. And then specifically, if you want to do something about climate change, there is an initiative that's started with the Paris Agreement a couple of years ago called the Space Climate Observatory, and that has a number of things you can find online, including free data of a number of different satellites alongside with analytics, so existing analytical tools that you can use for free in order to build applications. So I think to echo what has been said before, I think your biggest added value would be in connecting those tools, data plus tools, with specific use case, like actual needs in your city, in your district, in your region, because you're the one who knows best. And there's a lot of technology out there. There is a lot of needs, but connecting the two is actually the hard part. So I'd say focus on that.
I'll start with the free data. You should always use free data whenever you can get it. But where you should take that free data is find where are the holes in the data that you can get for free. So now I see all these free data, but I need higher spectral resolution, or I need a different wavelength coverage. And that's where you may say, well, can I buy this, or can I combine free sources? I think a huge area sort of ripe for young people who do machine learning is sort of in their blood, and earth science data needs, our robot overlords have to start combing through these data. So I think that's one place that you can start and make a big contribution quickly. But you should definitely use the free data when you can get it and find where it doesn't meet your needs. And that's where you should either build a satellite to do it or see if you can find somebody else who has perhaps a commercial app for it.
Okay. So to say that access to data today is no more a problem. To my knowledge, Copernicus system is the first data provider in the world, if I'm not wrong. We have also a long list of commercial providers. The Canadian company MDA, we have the US company Maxa, for instance. We have also IGEOS, the Italian company for radar data as well. We have Airbus, Defense and Space as well, with the Pléiades Neo, for instance. So access to data is not a problem. Now the business is in the how to change raw data into actionable information, into products, into services. More than a product, a service. Exactly what you said at the hotel. You don't need raw data. You need to have exactly what you need to move and to arrive on time to the meeting place. So if you want to develop a business, it's precisely to transform this data into something useful for different user communities. It's an important point. And yes, and just to refer to my past experience as I was director of the EU Satellite Center. That means precisely to use space data to provide intelligence services to end users. And the important aspect was to recruit data scientists. Today, one of the key substance who are recruiting, I would say, mainly data scientists, precisely to use this huge amount of data. And for when we speak about artificial intelligence, machine learning, what is important is precisely to have access to a big and huge amount of data, to have robust results at the end, and to feed the artificial intelligence mechanism, if I can put it like that. Yes.
If you allow me to reflect on your question. Actually, there is a bus who is coming here for free at 7:30. But I didn't come for free. I came with cream because the timing of the bus for free is not suits my requirements and needs. So I think the key issue is what your requirements, what it meets your expectations. So the free, there is a policy for the data free to be used for academia, for research. But for starting a business, if you use this data as a free for business, I think it's not obliged to use that. He has to get the data and pay for it to provide the services which will get paid for it. So I think the play with the free and the play with the cost of the data is critical on what you are going to do with the data. To get your learning and being qualified as a graduate to meet any jobs, I think this is a critical issue. They will use the free data sources, either data or toolkits, to learn how to work with the data. If he converted from work for a research center or academia or a ministry who has used the data for research, they will be capable to join this job with the basic understanding and skills. So free and not free, it depends on what exactly you want. Thank you. Just complementary to your question about the huge data and useless data. I think the trend, you can correct me if I'm wrong, that the new missions will think about artificial intelligence and the machine learning on board, just to deliver the service ready, rather than get the raw data and start to think about it. If you complement on this, would make a life easy for end users that instead of getting bloody hell data that not fully exploited and used, it will be on board ready-made services, downlink straight away. Thank you.
Thank you. I think sometimes it's not a good idea to try to have what everyone else is having. Not just because everyone is having a constellation, we should do the same, but go where there is no path and leave a trail. See what opportunities we have, and that's where you can have like a major impact on everything. So there we have like 2 quick questions, please, because we still need like 3 presentations, and then the dinner gala is going to start. So yeah, go ahead. And
okay, thank you. I'll make that quick. I have sort of a general question. I would like to hear your opinions since we are discussing space in Africa. For now and in probably 10 or 20 years, where do you see Africa in the space field? User for the data that's available, more on the analytics of whatever data is available, a potential market that investors could be attracted in technology development or owner in the coming years. I'd like to hear your opinions. And also, what are the key pillars that African continent should focus on in order to have like a brighter future in space? Thank you.
Maybe I'll go first because mine is a very focused answer having to do with astronomy data. All the astronomy data that NASA and in collaboration with ESA and the Canadian Space Agency, when we collaborate, those data are open at least 1 year after they come down, and often right away. And so what I would like to see is contributions from African scientists to those data, because what I have learned at NASA is that diversity of thought is what really drives scientific innovation. And so we have many nations in Europe and North America collaborating, and I want to see African nations joining that, because your backgrounds bring a diversity of thought that will discover and look at the universe in new ways.
just to add precisely, we need African experience or views concerning space and the use of space. And the case of Angola is a fantastic one. At ESA level, we have regular contact with Angola on space activities. And what you are doing is amazing, really amazing. You're not a big team, and you are very dynamic, active, etc., to imagine the solutions, etc. So just to mention your case, and it's exemplary.
Yeah, I think I'll talk about that tomorrow, actually. Yeah. To your question, what do we see Africa in 20 years? I am a little bit more optimistic, and I think in 20 years we will be actually developing application upstream, because we have upstream application and we have downstream application. And I think in 20 years we are going to be developing those upstream applications, sending satellite to space, because there is a huge problem in terms of high resolution satellite data in Africa. Usually, if you go, for example, to Google Earth, or you try to get high resolution satellite data in Africa, you will only find available or frequent satellite image in urban area, because I think in a commercial sense, that's where the company that provide those satellite data, I think they will make money. But if we go to forest and other region, we don't have enough satellite data. So that's why we need to send our own satellite. But I think for now, we should focus on downstream application, because we don't need to spend a lot of money to develop them.
Well, we have one last question here.
Yeah, actually, I'm sorry, a couple of questions, but it'll be very fast. Because of the climate change, there's a big problem with food security, and this had been discussed a lot in COP27. And a country like Egypt, you would try to find, and this is the same for most developing countries in Africa, you would try to find places where you could produce as much food as you can. And in a place like Egypt, we have around the north coast, there is an area that receives sufficient rainfall that could sustain agriculture. But the problem is the area is plagued with mines, land mines since World War II, from German side, from British side, the Allies and the Axis. And I think we also have a problem like that in Sinai from the Israeli side. So can Earth observation data be used to help with demining operations? That's my first question. My second question also related to military and strategy. I know the term illegal immigration and climate refugees have been a source of controversy, but in last COP27 there have been a discussion that about mobility. Climate mobility, the term is slightly changing, and also I think there have been a big team on African mobility for the climate. So in that case, are there space and Earth observation modeling for the patterns of human displacement because of climate change, especially across the Mediterranean? Also, when it comes to space, the analog planet data, could they help us to devise plans if everything failed for geoengineering, for climatic engineering, for example, using aerosols and stuff like that? And we have COP15 upcoming in Montreal in Canada. So there'll be a lot of discussions on allocating certain areas for biodiversity reserved, both terrestrial on the land and on the ocean. So in that case, our climate scientists and data scientists, basically, they are determining and preparing a map of possible places that could be used for afforestation, rewilding. That's pretty much it. I also have one last comment on the space companies. They depend on rare earth metals, and the mining operations for rare earth metals in Africa, they're causing a lot of degradation and pollution. And with COP27, there have been a big discussion and drive for ESG reporting. So in that case, what space companies get on the bandwagon and try to clean up their supply chain operations, especially when it comes to Africa and the mining for rare earth metals? Thank you.
Just so it's not only one question, you have a long list of questions. Just a few quick elements for my part about this demining issue. The European Union a couple of years ago worked on a project. The name of this project was Tiramisu, but it's for demining and precisely to find possible sensors to detect some objects. So the outcome was not fantastic, but we explored the possibilities of hyperspectral capacities to detect small changes at the surface and to find solution. This is one small element. In terms of mobility and displaced people, yes, we have some models to follow the situation. In fact, it's the first element. It's very difficult with the space systems to follow, to monitor mobile objects. Because the satellite is orbiting in a mechanical way, and it's not possible necessarily to. So what is important is to focus on the static positions. For instance, when there is a refugee camp, we have some elements we can determine. And also concerning the lanes, the routes used by the migrants or people displaced. We also use different possible techniques, radar, for instance, because the echo, when a human group is using all the time the same lines of communication, it's possible to determine the echo, the reflection is different, and we can determine the different and also the final step of this migration flow and move is the coastline, because people want to take a skiff and to go at sea to go to Europe, etc. So we are monitoring some coastline in Africa or Turkey, for instance. And also we have indicators of activities. I have a concrete example to show, but I did not prepare these slides. Yes, just quickly some answers.
Well, I hope that answered your questions. We would like to move very quickly before the gala dinner because we're really late with one last presentation for today. Two, by the way, are postponed for tomorrow, so we're not missing on anything. So there's a presentation by Mr. Tristan Laurent, and yeah, let's see what he has to tell us. No, no, it's fine. I have it. I think I have it. Just, sorry for the mistakes. Yeah. So.
Oui, présentation absolue. Oui. Mais yes. So you want me to send it? Send it. Okay, just check my. Là, je comprends. Ok. Ah bon, ah bon. So we're gonna have to. Can I just make an announcement and then
Your attention, please. So after the presentation from Mr. Laurent, we will have to go for the gala dinner. So I just want to make a small announcement that after the presentation, we will have to direct to the other building, building number 4. So we'll have to go out and then go to the right side. Okay. If anybody wants to change into their traditional clothes, we can do that there. We have a clean place that we can allocate for you to do that. And then yeah, just make sure you are mentally prepared for delicious Moroccan traditional food, you know. I won't reveal anything about what we have in there, but just think about it, all right? But that doesn't mean you should lose focus from the presentation. Mr. Laurent has a very insightful presentation, so please focus on that. Thank you.
Thank you for your patience. Well, you can maybe use this one. Try it. It's on. Try it.
Yeah. Okay. All right. Okay. Is everything on? Okay. Okay. So I know everyone is eager to go to dinner, and even if you're not, I am. So I'll try to be as quick as I can be. And again, we can chat later on if the topic is of interest to you. So quick notes on this work that's been commissioned by the United Nations 2 years ago on the impact of global warming on our cities if we continue on our current path in terms of industrial pollutions, both methane and CO2. So you can probably recognize a few a few places here, and this is not too far off. We're looking at about 1 to 2 centuries at max, and then these will be this will happen 2 centuries from now if nothing is done as far as reducing our methane emissions and our CO2 emissions and more generally greenhouse gas. So this is really why we decided to go ahead and tackle this challenge at Absolute Sensing. We think this is a big problem, and so we basically looked at the issue and what can be done in the short term. And so we looked at all of the greenhouse gases, and what we found out is that methane is as I said previously, and probably we should start with this one, methane has 23 times the heat trapping capability of CO2. So what this means, and this is the chart you're seeing on the right, you're seeing above all of those arrows, these are emission scenarios. So assuming that we dramatically reduces both CO2 and CH4 emissions right now, today, we just turn, cuff the valve, we turn it off. So that's scenario on the right hand side. What will happen in terms of global warming is that CO2 will stay in the atmosphere for much longer than methane, and so the CO2 contribution to global warming will not see the benefit of that for centuries. Whereas if we turn it off on the methane side, then the positive impact on global warming will be seen in a couple of years, 10 to 15 years, according to the science. And so then, going back to this one, we looked at, okay, methane, where does it come from? So it's roughly half man-made and half, geophysical processes and so forth. And so what interested us was obviously the man-made part of it, and obviously oil and gas is a big contributor of it, to it. Sorry. And the problem with oil and gas methane emissions is that it doesn't happen at a particular place in the value chain, say at the exploration stage or the production stage or storage or distribution. It happens along the way, and there are emissions along the way, and those are small emissions. As I said earlier on, it's less than 50 kilo of methane released into the atmosphere an hour, and so having the ability to see that it's quite difficult. And so the way that it had been done previously was drones or just teams, so people just going out there on the field. If you look at oil and gas, about 60% of methane emissions are controlled. So you think of producing oil, you actually need to burn, and so that is a control process where they have a pretty good understanding of what they're doing. They are trying to reduce the methane emission from those controlled activities, but still it's something. But then there is 40% that's the uncontrolled part, and that can happen across 30 million square kilometer plus of land, across hundreds of thousands of areas of interest that are small areas of interest. And so and it's a global thing. So it doesn't just happen in North America or in Asia or in Africa. It happens really pretty worldwide. So typically when a problem is worldwide, satellite is a good thing because you get coverage with satellite. However, traditional satellites haven't been designed for local greenhouse gas detection, and so this is what essentially we want to tackle. Now this has an impact for Africa because. Africa is also, because of its economic activities, emitting some methane, primarily, obviously, from the fossil fuel industry. Now, Morocco, you can see, is actually a good it's a good actor on the ranking on the right hand side. But we're essentially trying to come up with a system that can help countries, including in Africa, to decrease those numbers. So solution is to go ahead and first have a detector that's able to look at those very small emissions. And so this has been, at Heart, we are a sensor company at Absolute Sensing. We've been developing the technology in one of our sister companies called Absolute System, and it took us 10 years to develop this sensor technology. So it's a shortwave infrared payload that uses MCT APD technology. And the important thing with it is that we're able to miniaturize the sensor. Typically, those sensors we were selling it to Airbus, to the big primes, but this time we decided to go ahead and use it for our own needs. So to miniaturize the sensor technology and fit it with a cryocooler. And the important thing with again methane detection is you need to have radiometric and spectral resolution, much more than spatial resolution. And in order to do that, you need to have a very good signal-to-noise ratio, which you can only obtain if the thermal management on the sensor level is really, really good. We're talking less than 50 Kelvin at the local level. So all of those, the detection threshold is obtained by with this breakthrough that we've been able to achieve on the sensor technology. So that's what you see on the left-hand side. And importantly, the little tab below is you need to be able to detect small leaks regardless of the scene you're looking at. So when you're looking at methane, you're looking and all gases, you're essentially looking at sun reflectance. And so if you're looking, for example, in the water, you're essentially staring into the abyss and you're not seeing much. So we've been able to develop both on the hardware and the software side of things solutions so that our detection threshold is the same in a land type of albedo scene as it would be on an offshore platform, so a maritime scene, which is extremely important because in oil and gas, the vast majority of sites are actually offshore, where emissions are happening. I mean, and then on the right-hand side here, I'm referencing a couple of folks that are also trying to come up with satellite solutions for methane detection. Another very important part of the problem has been said earlier by one of my colleagues in the previous panel is revisit. So in those very high in those areas that are extremely sensitive that we've mapped, we want to achieve daily coverage. So it's about 5 million square kilometer of priority areas of interest where we want to have daily coverage, and then worldwide about weekly. And so that's why we're putting up 24 satellites in order to do this. We're working with world-class leaders, well, each leaders in their own field. So we really focus on the sensor part of it, on operating the constellation. We are the constellation operator, and on the data processing chain up to L2. And then we have a partner, Kairos, a French company based out of Paris that's a leader in analytics products using satellite data for and looking at methane is one of their top use cases. So we're partnering with them. We're partnering with Total, which is an end user for us and who's going to help us in the CalVal campaign. Absolute System, I talked about our sister company, CS Group, on the ground segment side of things to essentially come up with the satellite control center, the satellite planification center, and so forth. Labs as well, French labs, Onera and the LSC, to help us on understanding what we're looking at and making sure that our data is complementary with the Sentinel data and generally the Copernicus data that's available today and that will be available in the upcoming years. So what you see here is kind of, for the guys, I'll pass through it quickly, but for those that are interested in the technical aspect of how we do radiative transfer and essentially data processing, and talk about that later on. once we're done. And and then finally, we're looking at a fairly big satellite. It's going to be about it's going to be a microsatellite class, about 100 kilo class satellite that we're going to be putting up. First satellite launch is end of next year, and then the rollout through 2025 to arrive to the 24 satellites. So I hope that this will contribute in a positive way to fighting climate change, and invite you guys, if you're interested in the subject, to come and talk to me later on. I'll be available. Thank you very much.
Thank you very much, Tristan. I think if you have questions, like Tristan will be with us. I hope this will not be bothering with you during the dinner or during a break outside. So our gala dinner has already started. We should be there already, but I hope we were up to your expectations. If you see anything to improve, if you have any questions, we can address them tomorrow. Feel free to reach out to me, to Fahd, all the organizing team. We are here for you.
All right, so please, I'll ask you to leave the room, and then we're going to the building on the other side of. So we go out, and then on the right side. Okay, I'll help you to direct over there.